All right, so welcome everyone to today's session on revolutionizing epilepsy care, how AI/ML on AWS cuts diagnosis time by 70%. This is a level 300 session, and just to be mindful of other audience members, if we could please just make sure that we have our phones on silent. Also, in case anyone hasn't already downloaded the AWS Summit app, if you guys could just all download that, that's where you'll also be able to give our speakers feedback. So, about the session, today you're going to learn more about the Australian Epilepsy Project and how it's transforming lives of people living with epilepsy, leveraging the power of AI/ML. There will be a video to introduce this session first, following which we will be hearing from Juan and Jonas. Enjoy!
Seizures took over my life, so I would have quite convulsive seizures. I was a teenager, so couldn't go to sleepovers, go out to parties, and couldn't study.
When I was diagnosed with epilepsy 20 years ago, it was an awful way to live.
Clearly this is a very common neurological disease and it has really wide-ranging implications when it comes to health, safety, independence with driving, employment, cognitive function, so their concentration, their attention, their thinking, their learning, problems with their mood and with anxiety and with depression.
A lot of epilepsy diagnosis is done in silos. People have an EEG, they'll have an MRI, some genetic screening. The one thing that this project offers is an integration of all that.
If we can develop a diagnostic tool, we can then disseminate that to anyone. You don't have to be an epilepsy specialist like me.
This is a model that's outside the bricks and mortar of a hospital, and yet it's taking the expertise that's currently only contained in a hospital out there to the whole population. Instead of having to get to a centre after years of waiting and finding the right person with many false starts, we meet people in their homes at the start of their journey.
I've been seizure-free for 5 years. It shouldn't be that I'm lucky.
It's been 12 years since I had surgery, so a long time. I hope that others can have the same benefits that I've experienced.
Well, hello everyone, and welcome to this session. I hope you can hear me as well. Yeah, good, great, thank you. So my name is Juan Mejia, I'm a solutions architect here at AWS, and today I'm sharing the stage with Jonas Haderlein from the Australian Epilepsy Project. And we are here today to tell you about the story of the Australian Epilepsy Project and how they're leveraging AWS to transform and improve the lives of people living with epilepsy. We will focus on the use cases where they have used AI and ML to improve processes, such as accelerating the process of diagnosing a patient by up to 70%. So, Jonas, thank you for joining us today and for wanting to share the story with everyone. Please tell us more about the AEP.
Yes, most certainly. Thank you very much. So, as we've just all seen in that video, epilepsy can be quite a debilitating disease. But did you know that roughly 1 in 10 people will have a seizure in their lifetime? And roughly half of those will go on to be diagnosed with epilepsy. So it's actually quite probable that most of you know at least someone having epilepsy. All right, now what is the Australian Epilepsy Project? In a nutshell, it's a new model of care that enables a population-scale precision medicine tool on the cloud in AWS. So how does this decision support tool work? There's 4 main pillars to it. The first one is the network. So we have a network of scanning sites all across Australia, and this is where we do most of the data acquisition, which is the second pillar. So when I say data acquisition, what I mean is it's mostly MRI scans, but there's other things as well, and I'll be talking more about that in a second. The third one really is the online data platform, which our neurologists can use. They can refer patients, and then later on see all the analysis results of these patients. The fourth pillar is the AI and ML, the use cases that this talk is about. All right. What is new to this approach? In a way, we take the expertise that is usually only contained in specialist centers and hospitals. We take that and make it available on the cloud for all neurologists in the country to access. All right, let's come to the most important outcome of the AEP. It's the patient benefits. And when we see patients, we don't just see them once, we also follow them up 2 years later. And this enables us to measure certain improvements. So for example, we have a 9% improvement in work productivity from the start of the AEP up to the end of the AEP. Again, another very important measure is quality of life that our patients report. And there we already see an 8% improvement, which is amazing. And the third one that I want to tell you about is reduction in seizure rates. So over the course of those 2 years, our patients report a decrease of 8% in seizures. Now, what are the benefits for our treating neurologists? So for once, that is a 10% higher detection rate of brain lesions based on our very advanced MRI imaging that we are performing. Another benefit is a 50% of patients that we identify of being at risk of depression or anxiety. So why is that important? That's mainly important because neurologists need to know this for the drugs that they then give to patients, because this will have a big impact on, well, mental health for patients in their future. And last but not least, the big use case that I want to talk about today is that 70% of a certain diagnosis time we can save prior to surgery. And this is has something to do with language areas in the brain that we will hear more later about.
Fantastic, Jonas. I mean, these are some fantastic results that we have seen through the adoption of AI. But if you come from an organization that has been trying to adopt AI and ML for some time, you may have faced the challenge that it's not as easy to adopt. And the Australian Epilepsy Project didn't just start saying, yeah, we're going to use AI and ML, and they started from the day one implementing AI. They actually spent a lot of time building their data foundations. And looking at a report by the Harvard Business Review, it showed that 89% of organizations are actually willing to adopt AI and generative AI, but less than half of the reported, the respondents agreed that their data, less than half of the respondents agree that their data is in shape, that they have their data foundations to adopt AI. So it is a real challenge, especially in healthcare, where regulatory compliance and policies are actually impacting the adoption of AI. That's another reason why adoption is not as straightforward. And Jonas will share a little bit about what the Australian Epilepsy Project is doing in that space. So when we talk about building a strong data foundation, which is one of the key aspects that made Australian Epilepsy Project successful at adopting AI, we start with the storage layer. So when we look at the AWS services and what we offer, the Australian Epilepsy Project collects a lot of unstructured data, so MRI scans, PDF files containing medical history, and for that they use Amazon S3, which is virtually unlimited storage, highly durable, highly reliable. But they also collect information in surveys from patients and clinicians. And for that, they need a relational database service. So Amazon RDS has been quite handy because it's scalable, it's cost-effective, and there is no infrastructure to manage. They also use network-attached storage, and so they leverage Amazon EFS for that layer, for the container orchestration layer. For data synchronization, you may have a requirement where you need to move data from on-premises or other cloud providers into AWS. AWS offers a service called AWS Data Sync. And for data streaming, we offer Amazon Kinesis. Once the data is in store, then it's about processing this data. And what are the services available? Well, if the tool that you need to solve the problem is a modern big data platform, Amazon Elastic MapReduce, or EMR, is the right solution. If what you're looking for is for a modern data warehouse that's scalable, secure, is serverless, then Amazon Redshift is the right service. We also have Amazon Athena, which is a service that enables you to write ad hoc queries in SQL to surface the data stored in CSV files or Parquet files stored in Amazon S3 as well. We've developed specific healthcare services such as AWS Health Imaging, which enables customers to store DICOM-compliant images at the most cost-effective, in the most cost-effective way. It enables customers to analyze and query those images through APIs in health imaging. And lastly, we have the compute layer, so Amazon ECS, AWS Lambda, and Amazon EC2, that enables customers to build their custom logic. And the Australian Epilepsy Project has leveraged this quite a bit, so Jonas will share more information about how they have done it. And lastly is the consumption of this data. Once it's processed, then we start looking at who is going to consume it, what's the best way of surfacing these insights from the data. And we have Amazon SageMaker AI, we have Amazon Bedrock, and we have Amazon Q, that are AI and ML services that you can leverage for consumption. We also have, for business intelligence, we have Amazon QuickSight, which is a business intelligence tool powered by generative AI, so you can use natural language to create reports, to query the data. And lastly is if you need to build an API interface for your application for third-party applications to consume your data, then you can use Amazon API Gateway. So Jonas, take us through that journey of building your data foundation and tell us what services you use from this slide.
Certainly. Let me start with our data sources. The AEP data acquisition is in fact a fixed protocol, which means that we collect the exact same data from both our patients, but also from our healthy controls. All right. There's again 4 main modalities that we collect. The first one is MRI images. Every patient and every control gets the exact same scanning done. Second is an in-house developed neuropsychological assessment that, again, everyone undergoes for 2 hours. The third modality is that we get genetic data from a saliva sample that we collect. And the third modality is the individual medical history that every patient comes with. All right, so as you can imagine, with multimodal data, there's structured data, there's unstructured data. And here we just make use of the variety of tools that AWS gives us to store all this. So S3 for unstructured data, RDS for all the structured data, and we use a service called Authanc for storing the raw imaging data. The next ingestion layer is sort of the pre-processing layer. As you can imagine, we sort of need to massage our data a little bit to fit into our databases. So we use a range of Lambda functions to get the data into the shape that we want it to be. For the sort of bigger tasks, we use container images and step functions. And for the medical history in particular, we use a service called Amazon Textract, which does the optical character recognition for us. So in theory, we can use everything from a PDF to handwritten notes and ingest this text into our databases. All right. The next step in this processing pipeline is what we call the data nexus. And this data nexus is a data warehouse, an RDS instance, that we use for all the different model versioning, process orchestration, all these tasks that we need in order to keep our data updated at all times. Just to give you an example of what kind of different processes we are running here, we are using Amazon Bedrock with a Mistral model to convert free text into numerical data. So for example, we ask our participants, how much have you spent recently out of pocket on healthcare services? So that is a free text field, and we use the Mistral model, which we've seen performs really well on this kind of task, benchmarked to other open source models like Llama and whatnot, and convert this free text into a numeric field in our structured database. The next thing is, given that we have ingested all this text, we use an open source vector database called PG Vector, which we've tested a little bit with other vector databases out there. But in the end, what really sold this bit to us was that it was so seamlessly integrated into our existing Amazon RDS database. And I should say that all these AI processes that we have, they are listed with the TGA and are governed by quite strict clinical trials ethics. All right, let me close the loop. Once we have all this data assembled, we make it available to our in-house researchers, and then they can write papers and, well, do their research and feed all this knowledge back into our pipeline, which we might later on implement and productionize. And the other bit, of course, is that we make this data available in form of a baseline report to our treating neurologists. And they can access this data and these analysis results in a secure clinician's portal and make the best possible treatment decision based on this data. So this really is the decision support that I was talking about. Later on, they can then refer the patients again into the AEP, and this closes the loop. But enough of the theory. Let me show you how this really looks for the neurologist once he logs into the portal. All right, what you see here is just sample data, of course. A neurologist can click on a patient, see all the different baseline information for this patient. He can access the reports, but he can also access, for example, the MRI imaging. So what you see here is an MRI image of this sample patient, and neurologists can, for example, look for lesions in the scan or for many other things that I, as a data scientist, honestly don't know much about. All right, to sum up, what is the AEP platform model? It's a secure clinicians portal that currently serves more than 100 clinicians in Australia. We collect a grand total of 8 gigabytes of data from every participant and process that into a total of 13 gigabytes of analysis results. However, we deliver a tailored automated patient report for each patient so that the neurologist can make the ideal treatment decisions. We don't just do that, but we also collect feedback in the end and ask the neurologist, did this report actually influence the diagnosis that you made in the end?
That's fantastic. Thank you, Jonas. So that's great. So the Australian Epilepsy project built their strong data foundation, and with that, they were free to start thinking about all the use cases that they could solve with AI. And I remember talking to you guys, and you had over 100 different use cases that you thought you could apply AI to, which was fascinating. It was a large volume. But the second aspect that has been key to the success of the adoption of AI is the variety of services, the broad range of services that you have access to iterate through the technology stack, so that if one doesn't work, then the other may work, and so on and so forth. So the AWS AI/ML stack offers from the very infrastructure that you need to build and train your models and host them in Amazon SageMaker AI. We also offer Inferentia and Trainium chips and GPUs for high compute requirements for training and inference of models. Then the middle layer is Amazon Bedrock. Amazon Bedrock is a service that enables you to build your applications with generative AI capabilities. You have access to over 100 large language models from our leading providers of large language models. All through APIs, you have all the tools necessary for it, so guardrails, fine-tuning of models, all the security and all the compliance that you need to build a secure environment as well. And then at the very top of the stack, we have Amazon Q Business, which is an AI-powered assistant that enables you to surface the insights that you have in your organizational data. So if you have data stored in S3 or in a SharePoint site and you want everyone in your organization to have access to using natural language, you can use Amazon Q Business, which is a ready-to-go application. There is nothing to be developed. You just enable it for the whole organization, and you point it to the source of data that you want the chatbot or the assistant to have access to. And we have Amazon Q Developer, which is a tool for developers to accelerate the development process, to find vulnerabilities in the code, and also to convert from one language of code language to another programming language, which is quite fascinating. So again, Jonas, can you take us through the journey and the use cases where you have used AI and what services you use from the stack?
Yes, with pleasure, Juan. Let me show you what the AEP report actually looks like. So in a way, the AEP report is the total sum of all the different analyses that we are running for our patients. So what you see here is a PDF document with all analysis results that are vital for neurologists to make a treatment decision. And let me stop the video right here. This is the use case that I want to talk about today. What you see here is a brain reconstruction of this sample patient, and you have regions in this brain marked as red. So why are they marked as red? It has something to do with what we call language laterality. And language, as you know, of course, is absolutely key to human interaction. And when it comes to surgery for epileptic patients, it is key not to harm those regions in the brain that are responsible for language. So in a way, we were working on a targeted approach to locate exactly those regions in the brain that are responsible for language processing. And it already starts in the MRI scan. Our patients are in the scanner, and they are asked to rhyme words. And this word rhyming activates language areas. And as a result, we can see which areas in the brain light up or are activated in the MRI scanner. So in other words, the basic idea, you stick your patient in an MRI scanner, you ask him to rhyme words, that then causes those areas in the brain that are responsible for language processing to light up, literally. And how this is usually then dealt with is that neurologists manually review exactly those scans. And then you can kind of imagine this as a video, not just as a single 3D image. They have to review a whole video. So how can you improve this with, well, machine learning? So the idea here is that you take the scan, you feed every single scan into an ML algorithm, which then decides which regions in the brain are above normal activated during this word rhyming task. And as it turns out, in 70% of cases, you can do an automated classification of which areas in the brain these, well, are activated. In the other 30% still require our in-house neurologists to look at the scans and to make the call. In any case, those same neurologists also perform sense checks on the results of this ML algorithm in the end by not just using the original MRI scan, but the enriched data set of MRI scan plus machine learning result. In a bit more detail, how this works, you start off with this 4D video, so a 3D scan, but a video of that. We process that with a time series model to drill that down into a 3D activation map, which then, by some map of certain brain regions, are then clustered into, well, individual activation scores, if you will. And then these are sort of the heavy lifting models that work in a container. From then on, it's just Lambda functions processing this data, comparing it with controls. And so that's kind of important because you want to know, is this activation more than normal? Is it less than normal? How does it compare to healthy controls? And last but not least, there's another Lambda function which turns these laterality scores into clinical output, which is, in essence, an analysis, a blurb that says, these are the language areas that we identified. Please take care when you perform surgery. So this is this use case, and thankfully time permits me to talk about 2 more use cases that we have implemented in the AEP. The first one is what we call the Medical History Explorer. As I've told you before, we ingest our PDFs. We use Amazon Textract to get the text out of these scans, say for example. And then every single sentence gets, well, sent to an LNAI research LLM. You might not have heard of this. It's quite a small large language model, specifically trained on medical data and medical text, research papers that is, and the ensuing vector is being stored in our vector database. And then, of course, we use a RAG approach to allow our neurologists to ask free text questions against the database, against this patient's medical history, which will then show him, well, an answer and the pertaining paragraphs in the text where these answers come from. But we've actually went one step further and collected frequently asked questions, which you will see in this video. So a neurologist goes to the Medical History Explorer and he can select a question such as, does this patient have a family history of epilepsy? And once he clicks on an answer source, our tool will then show him the PDF document where this question is likely being answered, as in this case, this particular page on that PDF. And this is just another use case about comorbidity conditions. Same principle. You select a frequently asked question, and you get the answer in the portal. The last use case that I want to talk about are our patient summaries. So all our baseline data that we collect from our patients is sort of put into a prompt form by a Lambda function, and it's being sent in SageMaker AI to an OpenChat 3.6 model, which we have compared a little bit with other models, and we've seen less hallucination with this one in the medical context. So we were actually quite content with this model. We've implemented our own custom guardrails just to make sure that there's no hallucinations going on. And in the end, you can see the result in the portal again, which this video shows. So you can click on an Insights tab, which then shows you the patient summary as being generated by the LLM.
Thank you very much, Jonas. I hope you enjoyed that and it was quite insightful as well. Thank you very much for being here in this session. Again, it's been a pleasure working with the Australian Epilepsy Project and Jonas and the rest of the team. Thank you very much for attending. We hope you enjoyed this session. If you can please leave some feedback for us, we'll really appreciate it. But please enjoy the rest of the day. Thank you very much.